Think like Tesla.
Think like Tesla, Micah here, with some thoughts on electrical safety. We're going to be doing some experiments here in a bit, so I want to point to people to this video as kind of a disclaimer to be aware of your surroundings, be aware of your assumptions when you're working with high voltage. Now this video, by the way, is not a replacement for actual training in high voltage safety. So, and by way of illustration, we're going to look at this Chinese bug zapper tool, which I've taken apart in earlier drafts of this video, which did not have audio. So I figured you guys deserve the best. How about a recording with audio? Anyway, I took this apart and I looked at the circuit, and it looks like this. So can you spot any safety-related problems here with this? These two bigger capacitors are not marked at all. 4 diodes, big honking power resistor, which turns out is directly across the AC line here. Well, directly across that, and these LED, 6 blue LEDs. You know, back in the day, bug zappers had actual infrared lights in them to attract insects. These aren't infrared at all, or sorry, ultraviolet at all. These are just plain old blue LEDs. But anyway, if you look at the circuit, so the hot side here, actually, if you plug it in facing upwards, the writing is upright. The hot side is actually on here, and this is neutral on this common bar here. So yeah, if any of these resistors would fail short, you could potentially have live voltage across here. And if you plug it in upside down, which the plug is not polarized, so there's no protection against that, then you could have a hot energized circuit inside there, even with the switch off. So that's not good. Aside from how flimsy this protection is for little fingers. And also these capacitors, these guys, are energy storage devices, and there's nothing in here other than their own internal leakage through crappiness. There's nothing to discharge them. So you could unplug this from the wall, and it could still have quite a nasty surprise for you minutes, maybe even hours later. So just wanted to say, the number one tool for electrical safety is your brain. Use your brain. Very carefully look at any assumptions that you are making, because you are literally staking your life on your assumptions being correct. So we can talk about some of the specifics later on, but know about isolation. For example, parts of this circuit could be hot, could be live, even if the switch is off. So pay attention to when that might happen in other circuits that you're working on. What else? There's danger lurks in many places, right? You could get burned, you could get electrical burns, you could get RF burns, you could get electricity going through your heart, can kill you. Even just touching a soldering iron on the wrong end, it's not too fun. So yeah, I don't like to talk about it's not the volts or the amps or whatever that kills you. If you're thinking at that level, you're probably overthinking it. You just need to be very careful. If it's running off of a 9-volt battery, probably not lethal. If it's running off of line voltage, you better be careful. And circuit breakers are there not to save you. They're to prevent the wiring from burning, from melting, from the device from catching on fire. Ground fault protection circuits are the things that protect you, the human being, because they trip off with very small amounts of current. So yeah, don't be like this guy. Be safe. And we're going to do some experiments coming up here that have some cool stuff going on, some potentially dangerous stuff, some potential surprises if you're not alert. So be alert, be alive. All right, more stuff coming soon. Thanks, guys. Okay, for our bonus content, we're going to look today inside a video protection unit. This is a lightning arrestor. So what inside this little box can protect the thousands of amps that come in from a lightning strike? Let's find out. Got these screws loosened a bit. Let's just get them out. So yeah, another safety thing. Sticking antennas up into the sky can present its own hazards. Come on, little guy. All right. Looks like we have, this might be some kind of a gas discharge tube. Get it on the camera here. It's kind of nice that these connectors plug in and out. It says 75 ohms, but these have the PTFE insulators in. Might be 50 ohms. So it looks like this guy here is doing the heavy lifting. I'll see if I can find a data sheet on that. But, there we go. Stay tuned for the big experiment coming soon.